This is part 2 of inverse functions. What I'm going to do on this next screen is take a look at original graphs, see what happens on the horizontal line test. If I draw any horizontal line, how many times does that horizontal line cross our graph? Just once. For each horizontal line, it just touches once. That means this does have an inverse function. Go to this one. Draw in the first horizontal, and I've got a problem because it's crossing twice. So this one does not. This one was yes. Go to the next one. Horizontal line, horizontal line. Every horizontal line I have drawn just crosses one time. Therefore, this graph does have an inverse function. Draw this one. And here we're intersecting twice. Therefore, this does not have an inverse function. A function that passes the horizontal line test is said to be one-to-one. One-to-one also means that no two different ordered pairs have the same second component, meaning the same y value. So here was my parabola. I know I'm going to fail the horizontal line test, and the reason I fail the horizontal line test is this. Look at that y component. It's the same y component as that. So only one-to-one functions have inverse functions. Something must be one-to-one to have an inverse function. And how we know it's one-to-one, its y component does not repeat. Use the graph of f to draw the graph of its inverse function. The first thing you want to do is be sure this really is going to have an inverse function. And the way we're going to know is to check out the horizontal line test. Every horizontal line I would draw here is only going to cross one time. So that says I can proceed. This original function will have an inverse function. If I want to find the inverse of this function, I need to think about what the definition says about inverse. The definition just says swap out your x and your y. So if the ordered pair 0, 1 was on my original graph, then swapping x and y, I get the ordered pair 1, 0. It's going to be on my inverse graph. So I put a dot on 1, 0. If 1, 2 was on the original graph, swapping those out, I get 2, 1, which will be on my inverse graph. Same thing with 4, 3. Swap them out, becomes the point 3, 4. Over 3 up 4 is about right here. Now I'll try to draw this as a curve. It's just hard to do with this tool. One way to check that is to take this line y equals x, which is our line that goes right through the middle there, and visually inspect, does it look like if I folded on that green line, this would land on this? And the answer is yes. So we have drawn the inverse function. So all you have to do to draw an inverse function is to find a couple points, swap your x and your y, plot those points, and connect the dots. And you need to connect the dots knowing what your original function was. This was a curve, so I knew my inverse was going to be a curve. Watch this next one. This was a line. Here's some points I have already picked out. Let's do the swapping. 1, -1 needs to become the point -1, 1. So -1, 1 is here. The point 2, 1 needs to become the point 1, 2. Over 1, up 2. The point 3, 3, when I swap it, just stays 3, 3. I know my original function was a line, so that my inverse function needs to be a line. I'm not thinking about making a curve out of those. I made a line. Now let's check it with the diagonal line, which is right here. Does it look like the green would fold over the blue to land on this original? And the answer is yes. Putting this all together, you're going to be asked on some problems to find the inverse of a function. Now this is a restricted domain, and that's okay. You'll see this on the graph. Graph f and the inverse of f in the same coordinate system. So I started actually by doing the algebra, then we'll look at the graph. F of x equals x squared minus 1, but this is valid only if x is greater than or equal to 0. I don't need to do anything about that x greater than or equal to 0 just yet. So I'm going to do my steps, swap out and put a y in place of f of x, swap your x and your y, but notice something. Instead of it being x greater than or equal to 0, it has now become y greater than or equal to 0 because I swapped my x and my y. My domain restriction is now a range restriction. Solve this for y by adding 1 to both sides, and technically we would end up with plus or minus right here because we have solved by taking the square root. But this right here restricted me. It said I only want the y values greater than or equal to 0. That eliminates the necessity for the plus or minus. The black is the original x squared minus 1. How could I get those points? I could get those points by just doing a t-chart. If you put 0 in for x, 0 squared is 0, minus 1 is negative 1. Put 1 in for x. 1 squared is 1, take away 1 is 0. Put 2 in for x. 2 squared is 4, take away 1 is 3, and there's your point, 0, negative 1, 1, 0, over 2 up 3. And I draw it as a curve because I do need to recognize when I'm graphing x squared, it's going to be parabola-like. It's not the whole parabola because we had to restrict it to greater than or equal to 0. So we only got half the parabola. We get kind of the positive half. All right, now to graph the other one, I'm going to take these points and swap them around. So instead of 0, negative 1, I'm going to graph negative 1, 0. Instead of 1, 0, I'm going to graph 0, 1. And instead of 2, 3, I'm going to graph 3, 2. And that red curve is my inverse. And you can take a look at the blue line I already have here. That's your line y equals x. The red is the inverse of the black.